Okay, in the last video, we looked at what molecules, covalent molecules, really look like. How the electrons, we don't think of electrons as point charges orbiting the nucleus. We tend to think of them now as being areas of negative charge cloud, and these clouds can only occupy certain defined shapes, and those shapes are called orbitals. And we saw quite a few molecules with single bonds. Now we want to have a think about what happens when we have a molecule with a double bond. Okay, so let's think about ethene. Ethene, which is C2H4, and so we've got a double bond between the carbons, and each carbon has two hydrogens attached. If you recall, carbon always forms 4 bonds, doesn't it? Hydrogen always forms 1, so that's that structure is fine. So if we draw a dot cross diagram for that, it might be easier to draw the carbons in 2 different colors. So I'll do a black carbon and do a blue one. Okay, so and then we've got hydrogens. So let's draw the dot cross diagram for that. Okay, so here we've got a double bond, so we've got 2 crosses, 2 blue crosses from this carbon, and we've got 2 black crosses from the carbon on the left. I'll draw the hydrogen electrons as red. And the same on this side. So yeah, the carbons there, I think they've got fall out to shell, so that's okay. Now we said before that you can't have more than 2 electrons in one orbital. So what's happening here then, because we've got 4 electrons being shared? Well, what happens is this, and I'm going to draw this like a this is supposed to be a flat bit of paper. Okay, so draw a flat bit of paper. It lets me draw. Okay, so this is supposed to be a piece of paper. All right, I'll just draw like that to give it a bit of depth. Okay, so we're going to have our 2 carbon nuclei here, one there and this one here. We've got our hydrogen nuclei here. Okay, so the molecular orbitals for the hydrogens, between the carbons and the hydrogens, are pretty straightforward. We've seen them before, so you've got that sort of shape there, like that, and this one here. And each of those molecular orbitals has 2 electrons, one from the hydrogen, one from the carbon. Now, between the carbons, we have one of the molecular orbitals is just what we've been used to, that kind of shape. And that's actually called a sigma bond. But we've only got 2 electrons in there, so what happens to the other 2 electrons? Well, what happens to them is, I'll draw this, right, you have another molecular orbital, and these are all in the same plane, all these ones, they all fit on a flat piece of paper, and this one has got, this molecular orbital is made up of 2 parts. It's got one bit like a banana, which is sticking above the plane, okay, and then it's got one bit, which is like a banana, below the plane. And this is called the pi bond. Okay, so, and that has got a pair of electrons in it. Think of this pi bond as being, if you get a sort of long sausage-shaped balloon and you twist it and you end up with two separate bits, that's what this is like. So there's like a node there where they're joined together. And the pair of electrons, both electrons are spread equally throughout the whole thing. It's not like you've got one electron in the one banana on the top and one electron below. No, both electrons are in the whole thing. And that is what a double bond looks like. So a double bond is made up of two bits. It's made up of the sigma bond, which is fairly normal, and it's made up of the pi bond, which is like this banana-shaped thing. Right, let's just see how the pi bond would work. So if you've got two carbons here, and if we have, right, so we've got a pi bond there, one lobe of the pi bond, and you've got another lobe of the pi bond. I haven't drawn the sigma bond just to make it clearer, but if you think about, right, this is, imagine that little bit of negative charge there with the red, right, that carbon is going to be attracted towards it, isn't it, like that? And this one is going to be attracted towards it like that. So what stops the molecule bending is, of course, on the bottom, you've got this bit of negative charge we've got in blue. That carbon is pulled to that one is carbon, that one. So it's a bit like physics vector diagrams, whatever. The overall effect of those two things is just to pull the two carbons together. The two carbons are attracted together. You add up all those little forces there. Okay, so that is a double bond. I suppose the next obvious question now is, what is a triple bond? Okay, like you have in the nitrogen molecule. Well, a triple bond is made up of, there's a sigma bond in there, got two electrons in the sigma bond, and then you've got two pi bonds. And the two pi bonds, one is, they're at right angles to each other. So I'm not going to try and draw it because it's too complicated, but if you just look at the ethene diagram over here, if you imagine you had another pi bond, this would be in the plane of the paper and it'd be at right angle to this one, which is sticking up below it. And that's how triple bonds work. Probably just have another look at maybe what an oxygen molecule would look like before we finish. So here we've got oxygen. We have and just to remind us, so let's draw a dot cross diagram for that. So we've got a dot and a cross and a dot and a cross there because it's a double bond. Let's say that this oxygen is the dots electrons. We've only drawn two electrons of carbons 6, so we need to draw two lone pairs. So you've got a lone pair there and a lone pair there. And on this one, we've got two lone pairs there, one there and one there. Okay, so we could imagine what that would look like then. So we've got an oxygen nucleus there. We would have the sigma bond between the two oxygens. And then in addition to that, we'd have a pi bond. So I'll draw there. And the lobe of it, which is underneath there. And also we'd have two lone pairs. And remember, what do the lone pairs look like? Well, they look like this, don't they? So one would be like that. If you remember, the lone pairs are not as elongated as in molecular orbitals. You've got no nucleus. You've got no nucleus here to sort of pull it along. So that's what an oxygen molecule would look like. The nitrogen molecule, the nitrogen is a triple bond. That would be well, let's draw a dot cross diagram. So we'd have a triple bond here, dot cross, dot cross, dot cross. Nitrogen has got 5 electrons. I've only drawn 3 for each one, so we want 1 lone pair there, and we want 1 lone pair there. Right, the nitrogen, I'm not going to try and draw it because it's too hard, but if you look at the oxygen, you'd have 1 pi bond here, above and below, and you'd have another pi bond coming out towards you, like that. So you'd have 2 pi bonds, and then you wouldn't have 2 lone pairs, of course, you just have 1 lone pair on each nitrogen. Okay, so hopefully that gives you an idea of what happens with double bonds and triple bonds. Same rules apply. Each orbital is only allowed to have 2 electrons in it. So for a double bond, we need to have 2 separate bonding orbitals, the sigma and the pi.